But before writing the recursive DFS, I'd like to make some changes in this code. The first one would be to print and show that this is the iterative DFS. So what I'm going to do, I'm going to say iterative DFS. And another thing would be to print with a space at the end. Now, if we write this one, it's a iterative DFS. I think this works. Now we are going to write the code for recursive DFS. And to write a recursive function, we will have to always keep in mind that there should be a base case and there should be a recursive function. So that's how we'll try to design this one. So let's define the function and name it DFS recursive. Okay, here it will take the graph and the node from where we'll start the traversal, and initially the visited, the set that was defined, it will be none. Now here we will say if visited is none, that means we are creating an empty set. Now if the node is not a visited node, then what I will do? I will print the node with an end. Then I will add this node as at the visited set. Then for each neighbor of this node, I'll call this recursive function DFS, and then recursively all the nodes will be visited. Now I'm going to check whether the order of visit for recursive is same as the iterative one. But yes, here the reversed function will work and it will be useful. So I'm calling this recursive function with parameters. So this graph is the object and this is the attribute that was defined here. So you can see that for the iterative function, the object was passed, and here in this loop, the attributes was called through the object. So I can do this one, and here instead of passing the object, I passed the adjacency matrix. So both can be done, but you should be careful. Whichever you use, the corresponding function and the call should be appropriate, otherwise there will be errors. So now I'm going to run this and there isn't any space. So what I'll do, I'll simply add an next line. I'm going to run this code again. Right. So this is the iterative DFS and the order of the traversal of the nodes, and this is the recursive DFS, the order of the nodes. So both gives you the same output. They work different ways. The expressions are different. But yes, that's how we are supposed to apply DFS with recursion. Now we will solve a problem from the website.